Today we have three basic agenda. The first thing that we are going to discuss about is how to approach product design. There are two basic approaches. One is the traditional and the other one is the current. What is the lacuna of the traditional method and how the current method overcomes those difficulties? That's what we are going to see first. Then the second agenda, the point number, agenda point 2 is what do we mean by a technological vision for a product? What we mean exactly by, because the product development starts, the process of product development starts with a vision for the technology. What do we mean by that, and what this vision will do to product development? That's what we are going to see as agenda point 2. And the third thing is, I'll give a brief introduction to the term assignment which I'll be giving today. So I will explain what is expected out of the term assignment. This will be the one-time assignment. As I told you, you will have 4 weekly assignments. Of course, we are lagging in that. We just had only one. Okay? And then one term assignment for every term. A semester consists of 3 terms. The first term is up to first test. Second term is up to second test. Third term is the third test term. Okay? So, for the first term assignment, okay, I will explain what we have to do. These are the 3 things that I would like to discuss today. Before I proceed to the agenda proper, I would like to give some comments regarding the assignments that you have submitted. Point number 1, please don't just download from a web page, take a printout and give. If you do that, hereafter it will be 0. The evaluation will be 0. See, assignment is meant as a learning exercise. It is not imposition. You are not supposed to copy. I told you already, if you copy, again, both the parties will get 0. You are supposed to undergo the learning process. I only suggested we have a lot of internet resources. We are going to use the internet for this course extensively. But don't just download and then give it. You understand what it is and then write in your own words. It can be handwritten, it can be typewritten. You can use images from the internet, but I would still prefer you to draw the images by yourself. Either on the computer or using pen and pencil. Of course, in exceptional cases, some photographs, some good images you would like to exactly reproduce, no issues. And that is an exception. Using internet images is an exception. In the sense, it is an exception. We will overcome that lacuna over a period of time. Today we are tolerating it. Okay? We will not do this forever. But just downloading the web pages and then giving it, okay, is not acceptable as an assignment. Let us be very clear. And the marks for such a submission will be purely 0. This time we have not done that. Is that clear? Right. All of you would have the first assignment written to you. See, the basic idea behind this assignment is to understand how basically a free wheel works. Next slide please. Now as we discussed earlier, we have understood the functionality of a free wheel. We have understood because we have used the cycle for long. We know what a free wheel does. Okay, what it does, what a free wheel does. Pardon? When we go downhill, I need not pedal. I can keep still. Meaning, power transmission, or to be more precise, torque transmission. Power is a product of speed and torque, I told you. The torque transmission is one way. It takes place from the leg or from the pedal to the wheel, but not the other way. It means in one way the power is transmitted, in the other direction it is free rotation. In one way the power is transmitted, in the other way it is free rotation. The question is precisely how this is achieved. How do you achieve this? Have you understood? Unless you understand this, you should not write this assignment. You get my point. You have to, the exercises, you go through the images, you go through the text, try to understand how this particular functionality is achieved. This functionality is there in many mechanical appliances. Okay? It is there in your cycle. It is there in, suppose you will have a wrench. Probably when you go to the design appreciation lab, you can ask the faculty over there. You have a wrench in which you can operate the wrench in one direction. It will tighten it. But when you move it in the other direction, it will move freely. You understand? I don't know how many of you follow me. See, when you tighten a bolt with a spanner, what do you have to do? You have to put the spanner, okay, move it through this distance. After this, I will not be able to move because something will hit. Take out the spanner, reposition it, rotate it for another 60 degrees or 70 degrees. This is how you tighten a bolt, is it not? This particular wrench, what it will do is, I can tighten it in this way. Without removing it from the bolt head, I can bring it back. It will come freely. But the bolt head will not rotate. Again I can tighten it. You can see it. It is there in that. We have one or two spanners in the design appreciation lab. You can go and see it. What is the basic principle again? Again the same thing. Should you not learn how this is achieved? That is the purpose behind this assignment. Okay. But by going through, I might have awarded even 10. Many of my colleagues even might have awarded 10, but I get a feeling that you have not understood, you have not grasped the crux of the issue. Let us see. Now in this figure, I use the computer because I can point both the. Now in this figure you have this is a rim. Here you have a spring-loaded balls. These are springs. These balls are loaded by a spring. Meaning these balls will always be pushed out. They will be pressing hard against the inner surface here. Understood? You have balls here and these are loaded with spring, meaning these balls will be pushed out. Now imagine what happens when we rotate like in this direction. When this green color ring is rotated in this direction, what will happen? When this green color ring is rotated in this direction, this ball can always go inside. The spring will slightly get compressed and this ball will go inside. Yes or no? Yes. All that will happen is this ball will slightly go inside and this alone will rotate. This part will not rotate. Have you understood it? So this is the free direction. On the other hand, this is the direction. When it rotates in this direction. Now when this rotates in this direction, this is hard pressed. So if this has to rotate, this part should also rotate. By the very geometry of it, if the outer green rim has to rotate, by the very geometry, okay, the inner part should also rotate. That is how the geometry is designed. Okay, probably you can think is that there are certain lacunas in this particular freewheel design. There are certain lacunas. The power transmission efficiency, it can be enhanced. You can just think whether you can design some other freewheel of your own. You understand the basic science behind it, and then you can probably explore whether you can design your own freewheel, a new design which is more compact, which doesn't occupy much of space, which is more efficient in transmitting the torque. If you do that, probably that can be patented. But see, when you want to, see, the whole exercise is, if you want to design something new, many of you, I have seen many young students coming with many bright ideas. Sir, I want to design this, I have a design for new thing, I have a new engine design. But before you go into all this, you should precisely understand the existing knowledge. Then only I can develop something new. So what are the existing designs? You have to clearly understand that so that you can proceed further. Now, have we understood clearly the idea of freewheel? How many of you have not understood? Please raise your hand. I don't mind explaining once again. It is not a sin. If you don't understand, that is not a sin. Good. Two have died. Many other, they still hesitate. See, the idea is, sir, when you rotate in this direction, what happens? This ball will be slightly pushed inside. This will go into the socket. Okay. And this alone will rotate. This will not rotate. The inner part, the inner portion will not rotate. On the other hand, if it rotates in this direction, if it is rotating in this direction, immediately what will happen? This will, because it is pushed outward, okay, this ball will come and then hit this surface, and then the green portion can rotate only if the inside thing also rotates. So when you rotate this way, the power will be transmitted. So I can roughly tell you, this is the pedaling direction. This is the idling direction. Okay. Shall we proceed further? So hereafter, when you submit your assignments, take care. Don't just download some material and then submit it. And please remember, some of you have not submitted the assignment. Okay, we don't have any way to deal with that. If you decide not to study, absolutely, I have no powers to compel you to study. If you have not submitted your assignment, the marks you earn, you will lose. Okay, your internals will go down. It will become all the more difficult for you to clear. So the choice is yours. Every assignment matters, and deadlines are very important. This time we have allowed some leniency, but hereafter deadlines will be very strictly adhered to. Is it okay? Now we go to the topic that we have to discuss today. Now, the two basic approaches in product design. One is called a sequential approach. The other is called a concurrent approach. We are going to spend another half an hour discussing and understanding the sequential approach and concurrent approach. Now, as you know, any product design involves many steps. Realizing a new product, it involves many steps. Realizing a cell phone or realizing a new design of automobile, it involves various steps. Can someone list me the various steps? I want to have a conceptually new car realized. I want it in my hands. Okay. Can you list down what are the steps that you will undertake? First, you have to understand what is the need. You have to understand the voice of the customer. Then you have to list down the specifications. This is what I want my car to do. Okay. Then I have to develop some concepts to realize these requirements. I have to evaluate the various concepts. Okay. I have to model it, check whether this concept will really work. Then I have to go for a detailed design, meaning arrive at the drawing of each and every part. Whether I have to again do some testing, whether these parts will withstand the loads that are coming, whether these parts put together, whether they will work. I have to do some modeling and analysis. Then finally, these drawings are to be released. Released to whom? Released to my manufacturing department. So they have to make the necessary tools for making these components. They have to purchase new machinery, make these components, set up an assembly line wherein these components will be manufactured. Then after manufacturing, I will not send it to the market immediately. I will test again whether it is working satisfactorily. Then it will be sent to the market, it will be maintained, and then, as we saw earlier, many times nowadays products, I have to even think about recycling. The moment the product life is over, how I am going to reuse that product or recycle it so that it doesn't cause an environmental hazard, even those issues I need to address. These are all the various steps involved in realizing the product, or in the entire product life cycle. These are all the steps that I have to bother about. Now let us confine to the design stage alone. Basically, what do you understand by doing something sequentially? Doing something sequentially means you finish one, then do another, then the third thing, then the fourth thing. Then if I have say 1 to 10, you finish 1, 2, 3. Okay. Can you draw some parallel to electrical engineering? Circuits. So this is resistance 1, resistance 2, resistance 3, resistance 4. In sequential engineering, what we do is, at the end of resistance 1, you connect resistance. So sorry, this is not sequential engineering, this is series connection. In series connection, what you do is, at the end of resistance 1, you connect resistance 2. At the end of resistance 2, connect resistance 3. At the end of resistance 3, you connect resistance 4. This type of connection is called series connection. Series connection. Now, let's not go into too much of electrical engineering, but of course it will be useful. If necessary, we will go again. But let us come back. When you do things sequentially, there are a lot of issues involved. There are a lot of problems. Let us take our design activity. Let me take the design process. So first, you have concept, then some analysis, whether this concept work. I'm not going to make a very detailed list. Okay, I'm just writing the important steps. First is concept, then you have analysis, then detailed design. Okay, then I make tools. Then I manufacture. I test, then I maintain, I recycle. So these are the major activities. Okay. You have a concept, you analyze it, see whether that concept works, then you arrive at a detailed design. Then for that detailed design you make the tools, then you manufacture the various components, assemble them. I have left out assembly, okay. You assemble them, you test whether the whole system works, then you maintain it, okay. Then you recycle. Now this is the traditional, this is the approach. See, at the end of concept development comes analysis. At the end of analysis comes, is it not something similar to my series connection of resistors? Okay, at the end of one activity, another activity comes. So this is called sequential engineering. Is it okay? Are you able to understand what I mean by sequential engineering? See, why people resorted to this technique? See, people resorted to sequential engineering because they felt that only when the concept is ready, I can do some meaningful analysis. Only when you complete the detailed design, I can know what tools are required and then I can buy the tools or make the tools. Only when everything is, when the tools are available and when the detailed design is available, I can manufacture. Only when the final product is available, I can test. So at some point of time, sequential engineering made sense. But that is one big problem with sequential engineering. The problem is, suppose at some stage you encounter a problem. You have arrived at detailed design, you have made tools. At the same time, at some point of time when you try to manufacture it, it poses a lot of problems. It is very, very difficult to make. You realize only that. All these activities were carried out by traditional design engineers. You give the drawing to the manufacturing engineer. He says, sir, this particular part cannot be manufactured. Or it can be manufactured, but it will be very, very expensive to make. Okay? I can give you a lot of examples. Okay? I can give you a lot of examples where things are very, very difficult. I'm going to give. Okay? Things are very, very difficult to make. Then what should happen? The whole thing comes back. And then it has to be reworked. See, when you test it, something goes wrong. Okay, it is not taking up the load. Something fails. Then you have to go back. So this is not a very smooth flow. As we discussed earlier, many times the process has to come back and start from some other level. Many times it may have to come back and you may have to do many iterations. I'll give you an example. Suppose I have a part which is supposed to have a hole like this. are able to understand the part? So it is something like this. I'll give you another view. It's a rectangular block with a simple hole. Are you able to understand the part? This is how we have designed. Okay. Probably you have some threads. Or some peg is going to come here. Okay. You have designed it. This is one particular part. If you give this part to a manufacturing engineer, he will make a huge cry. Can somebody tell me why? I tell you, this is a part. Are you able to understand the part first? Okay. What is the part? It is a rectangular block, something like this, with a hole. Say the whole diameter is, say, 12 mm. If you give this drawing to a manufacturing engineer, he will make a big fuss. No, this cannot be made. Can somebody tell me why? Pardon? No, you forget about the drawing. It's not a mistake in the drawing. So this is the sectional front view and this is the top view. Now which angle projection you are using? First angle projection. So it's fine. Okay? It's fine. So the drawing is perfect now. I don't know what the shape will, of course I have to draw the axes and other things. Let me do it. Thank you for correcting me. Okay. I have done the axis. So this is the top view. See, first understand the product. The product is a rectangular plate with a hole. Now, let us try to understand the problem from the manufacturing engineer's point of view. You are the manufacturing engineer. How will you make it? It's a simple rectangular block with a hole. Assume that you machine the rectangular block. Dimensions are given. All the dimensions are given. Okay. You will machine the rectangular block. Then how will you make the hole? You have done it or you have done earlier some drilling? Okay. So you will drill it. You want a hole, you drill it. What is the issue? Drilling is very cheap. Drilling is very easy. It is one of the easiest operations. When I make a drill, okay, the drill bit will look something like this. So the drill bit will invariably leave. It can only make a hole like this, or it has to be a through hole. When I make a through hole, that is not an issue. Do you understand? Now, making such a small change in the drawing makes a lot of difference for the manufacturing engineer. The laws that I am trying to impress. Now, if this is because the manufacturing man, he doesn't know. Manufacturing man, he doesn't know whether such a conical end here is permissible or not. Or should this drilling end here, or can it continue till the other surface? Can it be a through hole? Through hole will make it much more easier. But making a blade hole, it calls in a very expensive process called electrical discharge machining. It cannot be done by any other process. Electrical discharge machining, please take it from me, it is at least 20 times costlier than drilling. If I can make, anything can be made. Okay. As a manufacturing engineer, the first thing that I should say is, anything that you design, it can be made by me. And everything is associated with the cost. The cost of drilling, and if you compare that with the cost of electrical discharge machining, It will be at least 20 times more. Is it really worth? Or can you make a small compromise? Permit a conical ending here or a through hole. So this input, I am just giving you a simple example because only this you can appreciate. There are many such issues that only a manufacturing engineer can put forward. In the case of sequential operation, if this drawing goes to the manufacturing, there are two things possible. Either the manufacturing engineer can refer it back, or he will spend 20 times more and try to make a blind hole with a flat bottom. Either of them is not desirable. Now, the basic problem with sequential approach is, the basic problem with sequential engineering is, it takes a lot of time. The manufacturing engineer sending it back to the design team, he has to rework, send it back again. If in the testing, if it fails, then it has to be sent back to an appropriate level. It has to be sent back to the analysis. Because in the analysis they should have predicted. They didn't predict. So it should go back to them. They should take the situation into account and then reanalyze. So in sequential engineering, when you encounter a difficulty, the whole process has to come back, and this increases the time to realize a product. So in typical sequential engineering, the time to realize the product is very long, and it has many other associated problems. Let us take what are the associated problems. The sequential engineering, next slide please. The sequential engineering is also called throw over the wall engineering. It is also called throw over the wall engineering. The first person is the designer. What he does is, he designs something, he is not bothered about what is happening in his next room, because there is a wall. There is a wall separating each activity, so the designer doesn't bother about what happens in the next room. He does some design, throws it over the wall. Now what the next person does? He is an analyst. He analyzes and then he throws it again over the wall. The next person, he is making a detailed design. He will make the detailed design and then again throw over the wall. Here he is not throwing it over the wall, he has a hole, so he just puts inside. The idea is he doesn't know what is happening in the next department, what are his concerns. Then it finally lands up to the manufacturing, or probably it goes to the testing. Okay, because that product, it cannot be realized. Okay, so this throwing over the wall approach, essentially sequential approach, the design engineer doesn't really appreciate what are the concerns of the manufacturing. Okay, the testing engineer or the analyst, he doesn't bother about what are the requirements of the testing engineer. So the sequential approach, it has a lot of difficulties. And many times if you do the sequential engineering, see, generally it is believed that, see, when I say, if I say something, if I make 100 points in oral communication, if I make, say, 100 points, if you are a very good listener and if I am a very good communicator, okay, you might grasp about 75% of what I said. The conditions are twofold. You must be a very apt listener and I must be a very good communicator, in which case see, every time an information passes from one hand to another, there will be some loss. So many times when you do it sequentially, certain vital information might get lost in the process itself. In the communication channel itself, you might lose some vital information. Ultimately, the voice of the customer may get lost. See, what is the objective in product design? Product design, it tries to, I repeat it many times, might be even boring to some people. Product design, it has to address the need of a customer. Product design essentially has to address certain need of the customer. And how a customer wins out that need? How does he or she will express that need? Sorry. He or she will express the need through what is known as the voice of the customer. That voice of the customer has to be grasped, and then it has to be translated into the product if the product is to be successful. If that is lost in your process, in your sequential process, then the product will never succeed. Can we go to the next slide, please? This is a classic case where the voice of the customer is getting lost. What the customer wanted was, the customer was having a tree. He just wanted a tire to be hung in the tree branch so that he can have a simple swing. Okay. But the customer description, the second diagram, is how the customer described it. He might not have expressed it, you get me a tire, put a hole on top, put a rope, tie it in my branch so that I can have a simple cheap swing. These are technical descriptions. Customer will not articulate it that way. Okay. So customer voice, customer described it as seen in the second figure. Okay. This is how the project leader understood it. How did the project leader understood the whole concept? Some rope tied to the trunk and a plank. Okay. But the whole thing is sitting pleasantly on the lawn. Okay. When the product was delivered, okay, they went and then installed the swing like this. Now the product was delivered like this. Now how can it swing? It cannot swing. Yeah, I don't want to disturb my product. So what should I do? Cut the tree and make room for it to swing. So they provided two props. Okay, they cut the tree and then the engineers, they made the swing to work. Again, the problem is not solved. The customer asked, where can I sit? Then they have decided, okay, let us remove the entire tree and then have the swing installed. Okay, you see, the idea is how to really grasp the voice of the customer, how to really understand the need of the customer and incorporate that in your product. Okay. Next slide, please. So for this, the sequential engineering is a big hurdle. When things happen sequentially, okay, it is going to, there are two issues associated, two major problems with sequential engineering. What are they? One is, it takes a lot of time. Number two, the voice of the customer is lost. What the customer really wanted, that is lost, and you may land up with something else which may not click in the market. So, we want to develop, we want to approach the whole problem of product design in a concurrent way. Concurrent means what? Literally, what does it mean? Concurrent means doing everything simultaneously. It is also called simultaneous engineering. Doing everything. No, but logically you must ask immediately, sir, how can I design as well as manufacture a product? Unless the design is complete, how can I manufacture my product? So the logical sequence is you design, you give me a detailed drawing, you give me a drawing which describes the complete product, then only I can start the manufacturing activity. Concurrent engineering, what it does is, at the early stages of design itself, see, concurrent engineering essentially, it is performed by a team, by a, what is described as a cross-functional team. The product design is to be carried out by what is known as a cross-functional team. What do you mean by cross-functional team? Group of people representing different activities involved in the design process. So, concurrent engineering, the first step is by a cross-functional team. So the first step in concurrent engineering is, if you want to design a product employing a concurrent engineering technique, what you should do is first we establish a cross-functional team. That is, you have a manufacturing, management, engineering, purchasing, process control, quality control, provisioning, testing, design, operations, from all these departments. Need not be so many in number. Okay, certain things can occur together. Purchasing and provisioning may be represented by a single person. See, the various domain knowledges in the design process, they are represented in that. Essentially, there will be a conceptual designer. There will be a person from quality control. There will be a person from manufacturing. There will be a person from maintenance. So, at every stage of design, the manufacturing engineer will give his inputs to the design. The maintenance engineer will give his inputs to the design. If you design it like this, my maintenance will become very expensive. Maintenance will become difficult. Can you modify it like this so that I can easily maintain? The moment he comes out with a blind flat pole, a manufacturing engineer will immediately say, sir, can you make it tapered or through so that I can drill it easily? So at every stage of design, all these inputs are taken and then the product design is realized. By taking all these inputs, the product design is carried out. And what is the advantage? The advantage is twofold. One is I can have my cycle time reduced tremendously because all the inputs are available right at the beginning. So later on, somebody cannot say, sir, this part cannot be manufactured. Since all these informations are made available right from the early stages, my cycle time is going to be less. And since the communication gap is eliminated, there is no throwing over the wall. Since that gap is eliminated, the voice of the customer can truly be represented in the product. Is it okay? Now, so this is one thing that I wanted to discuss, how the product development takes place. What are the two methods? Sequential engineering, concurrent engineering. What is the sequential engineering? Did you appreciate? See, now we condemn sequential engineering. You should appreciate the logic behind it, because that is how people were designing some 60 years back. Okay. See, it is easy to condemn a particular method, but that is how for over 100 years people were doing the design. So what is the logic behind sequential engineering? It made sense at one point of time. See, you first complete what you have to do. Then I will look what best I can do. This is the basic approach behind sequential engineering. When 10 operations are to be performed, you first finish your operation. I'll come and see how I'll do mine. So this is how it makes sense at some point of time. But what is the pressure today? The pressure today is the product life cycle is shrinking. Are you able to appreciate? The product life cycle is shrinking. What do you mean by the product life cycle is shrinking? We have discussed it in the previous class. What do you mean by the product life cycle getting shrunk? No, feel free. Sit down and can you give me an example?
Competitions are increasing.
Very good. Competitions are increasing. Okay. A same model of telephone. I don't know whether you have seen such model. We used to have a dial which used to rotate. By the angle through which it rotates, it determines the number. That dialing telephone, okay, in which we used to rotate it, it existed for over 30 years. But for 3 months, I don't see the same model of telephone. Landline telephone itself, the same model. Now you have hundreds of models. Now, similarly, if you take cell phone, I mean, a model, how long does it stay in the market?
2-3 months.
How frequently you change your cell phones? 6 months you change your cell phone. Okay. Almost the models, they get changed in the market every 6 months. Am I right? Almost a model becomes technologically obsolete after 6 months. Same with everything. Two-wheelers, okay, cars, automobiles, everything. Even washing machines, any electronic durable, televisions. People are talking about particular technology. Now people are talking about LED. People are already started talking about plasma. Okay. Even the way the technology is viewed is changing very rapidly. Okay. So the product life cycle has shrunk. So that puts enormous pressure on me to deliver a new product at a very short period of time. When I have to do that, the sequential engineering is not going to work, and I have to resort to concurrent engineering. How do I approach the problem? In concurrent engineering, I approach the problem basically with a cross-functional team, wherein representatives from various departments, they find a place and then they together take up the design issues so that I have all the inputs. I have inputs regarding manufacturing, inputs regarding testing, inputs regarding maintenance, inputs regarding recycling. Everything is taken at the stage of design itself. Is it okay? So this will reduce the cycle time significantly. It will also ensure that there is no loss of vital information. Now, the next slide. Now, when another closely related concept that I must understand, we all must understand, is the typical S-curve of product performance. Now, what do I mean by the S-curve of product performance? In the X-axis I have time, in the Y-axis I have the performance index. When I develop a new concept, initially the concept may not perform very well. So there will be a lot of technical obstacles. The product may not come out perfect on the first try itself. In the initial phase, there will be a lot of technical difficulties that I may have to overcome. So, the first phase is the growth phase. Initially, we will encounter a lot of problems, so the growth will not be very fast. At the first few instances, it will be only slow. But after I overcome the major technical obstacles, I may expect a fast growth. After some point of time, the performance may not be enhanced further because every technology has its own limitation. it reaches, what we mean is, the technology approaches the physical limits. After that, I cannot think of any improvement on that technology. I cannot change this, change that, and then improve the technology. The technology has reached its physical limit. That is, it has reached the saturation. The technology has reached the saturation. If you want to improve the performance, what can you do? I have to go for an altogether new technology. You get my point? So, every technology, this is true for any new concept. Any new concept, immediately it cannot be implemented. When I start implementing that concept, the output will not be very high. There will be a lot of difficulties. Okay? So, when I overcome that, the performance will slowly improve. Then it will, when I overcome the major technical difficulties, the performance may improve even dramatically. Very steeply, the performance will improve. But after some time, the performance will saturate. The technology will saturate. It may not yield. In economics, people used to call it as the law of diminishing returns. This is the point where people call it as the law of diminishing returns. Okay, when the technology saturates, the returns are not very extensive. The returns will be, see, this is true for anything. I'll try to give you examples, probably that will help you to understand better. Suppose this understanding is necessary across fields. Let us take the case of agriculture. Okay, I am cultivating rice in a field. Okay, do you know, for the first time when I cultivate, okay, probably there is a barren land, lot of stones, and it is not a cultivated land. So I make it suitable for cultivation. That is similar to the major technical objectives. I should arrange for irrigation. Okay, I should make the soil suitable. But I overcome. I may find a lot of stones or rocks. I may have to remove it. I must first make it a soil. Then I arrange for irrigation. Okay. So now, the moment I overcome the major technical objectives, in the first few years, the yield may be low. But after that, because I have not sorted out all the issues, I have not arranged proper irrigation, I have not arranged, the soil is not very conducive. But after 2-3 years, when everything settles down, okay, when the major technological obstacles are overcome, the yield may become very good. But if I keep on cultivating rice in the same soil, okay, again people say the fertility may get lost. So it reaches a saturation, and then in some instances it may even decline. The performance may even go down. Okay. Now take the case of VLSI, very large scale integration circuits. How do you think, what is the speed of your computer that you have with you? People are now talking about, say, gigahertz. Okay. The processing speed of the computer is talked in terms of gigahertz. When 10 years back, when I thought of buying a personal computer, having 1 GB hard disk was a big thing. People used to proudly say, I have a 1 GB hard disk. Even for the labs. Okay, I have a 1 GB hard disk. Now people are casually talking about 1 TB hard disk. Now how this technological performance is possible? It is possible through very large scale integration of circuits. VLSI, the developments in VLSI, okay, is responsible for this. But please take it from me, 1 gigabyte to 1 TB has happened. 1 gigabyte, for common understanding, let us say 1 gigabyte to 1000 gigabyte. It has taken place, it has happened. But 1 gigabyte to 1 million gigabyte, 1000 has happened. But 1 million gigabyte, please take it from me, it will not happen with the existing technology. The existing technology had already reached its saturation level. And altogether, new technology has to come. You understand? That has already started coming. Okay? That has already started coming. Let me tell you, what is the internet speed? Let us start with something which we can understand and probably go to VLSI. What is the internet speed that we are talking now today? But people are casually talking about Mbps, 100 Mbps. Broadband, everybody says they will provide 100 Mbps. Okay? What was the situation 5 years back? It was obviously kbps. How did this happen? From Mbps to okay, megabytes per second, Mbps, okay, megabytes per second to, kilobytes per second to megabytes per second. How did this happen? What? No VLSI, sorry. From electrical transmission of signal to optical transmission of signal. That is how you could achieve this. Do you understand? This is how you must achieve, this is how you could achieve the speed. So the technology was altogether different. Earlier, people were trying to, as an electrical signal, the communication was taking place. That reached its saturation. After that, an altogether new technology has to come. What is that new technology? It is an optical communication. What do you mean by optical communication? The data is converted into light signals which are transmitted through fiber optic cables, which are again converted into electrical signals at the ends and then fed to the computer. You understand? All transmission, reception has to take place as electrical signal. So in between, data communication has to take place through fiber optic. This technology may exist from probably megabytes to even fiber optic may permit even gigabyte transmission of data. But after that, this technology has to saturate. If you want an enhancement, a new technology has to come. See, the product performance, you must see as the performance of a product. As a design engineer, if you have to have a vision about the product development, you should see in the x-axis I have time, in the y-axis I have performance. Okay. As a design engineer, you must see here I have taken relatively a short period of time. Now I am talking about vision, so I take a long x-axis. You should see it as a series of S-curves. One S-curve going like this. At this point of time, some other S-curve must take over and it should happen like this. At this point of time, another S-curve must take over. Do you understand? So the success of business is in forecasting when my technology is going to saturate and initiate development activity at the right instant so that I don't miss the wave. It is like it is riding into the sea. If you want to put your boat into the sea, you have to catch the right wave and then put your catamaran on that wave. Development has to be viewed as a series of whiskers, and I must catch the technology, and then only it will take you inside the sea. So at the right instant, you must forecast that this technology is going to saturate and invest my research in an altogether new technology, so that I don't miss the bus. So the whole development make right investments. Okay. Now, what I'm going to do next is to tell you a new technology related to the field of mechanical engineering that you might not have seen, okay, but that will be prevailing as a very casual thing in another 10 years or 20 years. Okay. Shall we go to the next slide, please? Please view it carefully. Okay. This is called a hexapod. Have anyone seen a hexapod? Have anyone seen a hexapod? No? Okay. First observe carefully. Okay. The bottom disc is fixed. Now you have 6 points at the bottom. Okay. All these joints are spherical joints. Spherical joints mean a ball and a socket joint. You know from your biology what a ball and a socket joint is. Okay. It can be a ball and socket joint, or it can be a universal joint. In the diagram it appears as if it is a universal joint. In the figure it appears as if it is a universal joint. Now, at the bottom plate you have 3 points. At the bottom plate you have 3 points. This is 1 point, this is another point, this is the third point. At each point we have 2 actuators originating. See, an actuator originating at one particular point is connected to the other 2 points. Okay. Similarly, we have a top plate which is moving. The bottom plate is essentially fixed. The top plate is moving. Okay. This is a hexapod. Okay. So, if the length of the actuator, if it changes, the position of the top plate will be changing. Is it clear? If the length of the actuator is changed, the way the top plate is oriented or position will vary. Essentially, any point in space has how many degrees of freedom? You have all started studying engineering mechanics. Any point in space has how many degrees of freedom? Yes? Here somebody says 3. Anything more, anything less? Any point in space has, please take it from me, you should never forget this, any point in space has 6 degrees of freedom. Any point in 3-dimensional space has 6 degrees of freedom. What are the 6 degrees of freedom? It can move along the x-axis. It can move along the y-axis. It can move along the z-axis. 3 over. Now it can rotate on the xy plane. It can rotate on the xy plane. It can rotate on the yz plane. It can rotate on the zx plane. These are the 6 degrees of freedom any point in space will have. So suppose I have x, y, z. A particle in space, it can move along the x-axis, move along the y-axis, it can move along the x-axis, or it can move along the z-axis, or the particle can rotate on the XY plane. What do I mean? This point, keep the Z axis as the axis of rotation. It can start rotating with Z axis as the axis of rotation. That is what I mean by rotating on the XY plane. Am I making sense? Sir, my standing instructions are, if you don't understand anything I talk, let it be a very trivial doubt. If I don't make sense, stop me. You have every right to do that. I repeat what I said. That the three translations are understood, three movements are understood. It can move along the x-axis, it can move along the y-axis, it can move along the z-axis. You understand that? Now the next point is, I have said it can rotate on the xy plane. So this is the xy plane. This is the point. What do I mean by it can rotate on the xy plane? By rotating on the xy plane, what I mean is, perpendicular to xy plane, I have the z-axis, z-axis. Now with z-axis as the axis of rotation, this point can rotate. That is what I mean by rotating on the xy plane. That means distance from the xy plane will remain constant. Similarly, it can rotate on the xz plane. What does it mean? Rotating on the xz plane means this point can rotate with respect to y-axis. Similarly, it can rotate with respect to z-axis. These are the 6 degrees of freedom a point in 3-dimensional space can have. Since we have started this, let us see what about a point in 2-dimensional space? 2-dimensional space. 4, 2, both are wrong? Okay, 3. As a compromise, somebody said 3, not as a compromise. Okay. The scientific thing is only 3. Huh? So it can, in two-dimensional plane, a point can move along the x-axis, can move along the y-axis, or rotate on the xy plane. That is, rotate with respect to z-axis. I cannot say z-axis because I don't have the z-axis. So this is with regard to 2 dimensions. How many degrees of freedom you have for a point in a 2-dimensional space? 3. Never forget it. Okay. Now, how many points do I have? How many degrees of freedom do I have for a point on a 1-dimensional space? Only? What is that? Movement along the x-axis. You cannot have any other motion. So, 1-dimensional space, 1 degree of freedom. 2-dimensional space, 3 degrees of freedom. 3-dimensional space, 6 degrees of freedom. Is it okay? Now, the hexagon, it can have the top plate, it can have 6 degrees of freedom, meaning it can move along the z-axis, it can move along the y-axis, it can move along the x-axis. This is x, this is y, this is z. Okay? Or it can rotate along the y-axis. Okay? Let this be the top plate. Let this be the top plate. Let this be the top plate. Okay? It can move along the x-axis, move along the y-axis, move along the z-axis. Okay? Now, it can rotate about the x-axis, it can rotate about the y-axis, it can rotate about the z-axis. It can achieve all 6. That is why I need the 6 cylinders. For achieving 6 degrees of freedom, I need 6 activators. So this particular arrangement is called I'll come to the name later because that will betray something else. Let us go to the next slide and then see. This is called a serial kinematics. This is called a serial kinematics. This type of machines you would have seen everywhere. Have you seen any of these machines already? Lathe. Okay. Okay, we'll take lathe. It is easy. Okay. If you see the lathe, the tool post has two motions. Okay. Either the tool post can be moved, okay, along this axis, that is the z-axis. Why this axis is named like this, we'll see later. This is one axis, this is another axis. This method I call it as serial kinematics because if you see the x-axis is sitting on top of the z-axis. The x-axis is sitting on top of the z-axis. So at the end of the z-axis, you have the x-axis. Is it okay? You go to the milling machine. Or if you see this machine, okay, the base thing is the z-axis motion. On top of that you have the x-axis motion. On top of this I should have another arrangement which will provide the y-axis motion. The axis motions are connected. The axis motions are connected in series. Let me take a robo. The robo which we are all familiar. I am not talking about the movie. I am talking about the robos. Okay, I am sorry, I misled you. I said familiarity. Okay, you have to get familiar with these robos also. Then only you can design a robo like that. Okay, a typical robo is something like this. Is it not? You have a base link, at the end of which you have another link, at the end of which you have another link. This arrangement is called the serial arrangement. The different degrees of freedom are arranged one on top of another. At the end of one thing, another thing begins. Is it okay? This has a lot. All the machines that you see today, are what type of machines? Serial kinematic machines. All the machines, like your drilling machine, like your milling machines, lathes, all the robots, they are all serial kinematic machines. Please take it from me, the dexterity of the human finger cannot be achieved by any precise robot. The dexterity means the fineness of human hand. It cannot be achieved by, you spend any amount, a robot can never achieve that. The reason is twofold. You have a superior controller. Your brain is a controller for your finger, which cannot be duplicated. See, I cannot make a robot which makes a beautiful picture. Why? Because the required dexterity is not there for the robot. Because the reasons are twofold. One is the control system is much superior in the case of human beings. The brain is the one which is controlling the motion, that is superior. Let's not dwell on that part because I am interested in something else. You have a sort of parallel kinematics. You have 5 different fingers holding a brush. So by changing these 5 fingers by a superior control system, I can have a very good dexterity. Now all these serial kinematic machines, they are going to become extinct in another 30 years. Nowhere in another 30 years you will see machines like this. All motions will be carried out by, when we go back to the previous slide, all the motions will be carried out by the hexapons. Because the hexapons are more accurate. Because if we make a small change in the error, please remember that the error is going to be magnified subsequently. If we make a small error here, that will get amplified. If we make a small error in the angular position at the base link, that will get magnified when we have a serial arrangement. The parallel arrangement has many advantages. So all the machine tools, everything is going to be based on hexapons in another 30 years, and people have started working on it. I can show you some sample images. Can you go to the next slide? So this is a hexapod simulator which is used by Lufthansa, wherein you are able to appreciate the same structure at the base. You have actuators, 6 actuators, so it can simulate any condition. Okay. So next is a hexapod work table. Such work tables are available readily. I can take it, bring it, and then use it for my machine tools. So this is the base which can be fixed to the ground. Here you attach your table, whatever table you want. Okay, and this will be controlled by computers. Controllers have been developed. So if you want to move along x-axis, z-axis, it will move. If you want to move along x-axis, it will move. If you want to move along y-axis, it will move. Okay, it can be, all the motion can be controlled by the computers. So we have got already hexapod work tables. So this is going to change the face of the robots and the machine tools that we see today. This is what I mean by something becoming technologically obsolete and something taking over from that point. The VLSI did this. The CMOS technology is going to do this to the electronic world. Okay, the gate control technology is going to change in electronics. The way you control the tunneling gates in electronics, that is going to undergo a large amount of change, and that will introduce a new phase in increasing the processing speed of computers and microprocessors. Is it okay? So what we have seen today, next slide please. What we have seen today is two things. The concept of concurrent engineering, sequential and concurrent engineering, and the need for technologically aware. The need to be technologically conscious and aware and predict the way the technology is going to change. That is the very crux of being a successful product designer. Is it okay? Now I have 10 more minutes. Probably I'll spend that in discussing your. Now the first assignment, the general topic is let us learn from failures. Now I'll read first. Given below is the list of well-known engineering failures that occurred in the past. I have listed 10 major engineering failures and I have not ranked it. Okay, these are some well-known engineering failures. A huge volume of well-documented data on these failures are available on the internet. As part of the assignment, the following questions need to be addressed. Briefly give the historical context of the product system. It is either a product or a system that had failed, so briefly give a historical context. Okay, whether it is contemporary, whether it is 200 years old, whether it is 300 years old, because technology is time sensitive. I cannot talk about a technology which was existing 300 years earlier without noting down the time. So briefly give a historical context. Give the salient features of the design. Give briefly describe what is the salient design aspects of that particular product or system. Now analyze these failures in detail. Analyze why it has failed in detail, and present a brief case of these failures, emphasizing why the failure had occurred. There can be multiple reasons. Many times it is multiple reasons. There are multiple failures leading to a disaster. Okay. See, people say one or two failures usually it doesn't lead to a disaster. People are talking about, in all the cases that I have listed, it is a systemic failure. It is not that failure had taken place at one point or 2 points. No. Multiple systemic failure had occurred. Okay. If you take any case, okay, failure had occurred at more than 1 point. That is why it had become a disaster. Now the fourth point is, put these failures, of course, we have an advantage. Always doing a postmortem is easy. Okay. Doing a postmortem is an easy job. Now we know all the things that has happened. So you see whether these failures could have been avoided by improving the design. If so, and what are your design suggestions? How do you think these failures could have been avoided? Now, can you understand, there are a few engineering concepts like a factor of safety and redundancy or anything else. By learning, by going through these failures, try to get an idea. I am not going to explain today what factor of safety is, what redundancy is. Okay. Try to gain your own, I am just underlining what you have to look for. Okay. Try to understand what we mean by factor of safety, what we mean by a redundancy. Okay. Or anything similar. Okay. Whenever necessary, give sketches. Okay. The assignment should not be just a downloaded material. The key ideas are to be understood and reproduced in one's own words. It can be handwritten or it can be typed. Okay. But please don't download something and then give it to me. I can as well do it myself. Okay. It is not a test on whether you are able to take a printout. No. This assignment is definitely not to check whether, if you just Google these words, you will get the website. I am not testing whether you could Google, neither I am testing whether you could take a printout. Many of you have done it, that is why I am saying it again and again. If such submissions are made, the marks awarded will be 0. The whole exercise is, see, unless you spend, let me be very frank, unless you spend 5 hours, you cannot do justice to this assignment. Okay, and I can find out, on just seeing your assignment, I can find out whether how much you have worked. Okay, so please take it seriously. It should be a learning exercise. And if you copy and if 2 assignments are identical, both of you I will be merciless. I have given enough warning. And myself and all my colleagues will be very merciless. If 2 assignments are identical, it will be, both will be 0. Okay, please don't share it. Now let us come to the interesting cases. There are many. Of course, I have shortlisted 10. Okay, if somebody has some special reason to have a change, they can approach me, I can change it. As on date, those registered numbers ending with 0 will take the 0%. Okay, those roll numbers ending with 1 will take 1. Is it clear? So, I have given, you will not work out on all 10. Please remember, you are going to work out only on 1. Okay. Now, let me give, in another 5 minutes, I will give you a brief introduction of what these failures are. Shall I start? Now, Ford Pinto. Okay, this This is a model released by Ford US. Okay. This model got, it has a distinction of, it was named by Times Magazine as the most disastrous car. Okay. The Ford Pinto, it was a model which was named by Times Magazine as the most disastrous car. Okay. I mean, in US, this was a model essentially introduced in US. The car will stop at some point of time, and then it will lead to a very light accident, and it will immediately burn. It will turn into flames. And there are multiple systemic failures in this case. I want you to analyze. Okay. Of course, in my next assignment, I am going to give another product of Ford, the Ford Model T. That is going to be for some other reason. That product is going to be analyzed for some other reason. Okay. That is one of the wonderful designs. The second assignment most probably is going to be some of the wonderful designs. Okay. Now we are studying disasters. The second assignment will be some of the great designs. Okay. And in that case we will take up Ford Model T, which was the first automobile in the history. That was a great design, but this is a disaster. Let us study about Ford Pinto. The first those RPN number ending with 1 is St. Francis Dam, also known as Los Angeles Aqueduct. Los Angeles was developing as a big city in US. There was a huge water shortage. They planned to construct a dam and bring water to Los Angeles. The duct was supposed to be for 320 miles. Okay. After about less than a year or about 1 or 2 years, the dam crashed, causing huge human casualty. And we are talking about Mullai Periyar after say many decades. A dam crashing after 2 years, less than 2 years, is a definite engineering disaster. Why it has happened? Now the third thing is Vasa of 1628 and Titanic of 1912. Okay. Vasa was considered as an epitome of the Swedish sea power. It was a Swedish ship. Okay. Many of you may not know history. Sweden was one of the superpowers of history years. All over Europe, okay, those who conquered sea, they were the superpowers. British could do it much better. So that is how they were the imperial nation. Those who, till the Second World War, the superpower status was for the nation which could conquer sea. Second World War and the end of the First World War saw the introduction of airplanes, the whole economics got changed. Before that, if you could conquer sea successfully, okay, you are the superpower of the world. Sweden was one of the contenders. Spain was one of the contenders. Many of you might have heard about the Spanish Armada. Okay, the Spanish Armada is a fleet of ships that Spain possessed. So they wanted to conquer the world. Sweden was also one of the contenders. Their dream ship was Vasa. Okay, after it was launched for 2 minutes, it was a dream ship. It just lived for 2 minutes on sea, it collapsed. Why it collapsed? Similarly, Titanic. All of you know about Titanic, so let me not talk about it. Okay, so they are separated by huge time frame. One was 1628 and the other one was 1912, but still it is worth. 3 Mile Island, it was a huge nuclear disaster. Similarly, Chernobyl and Tacoma. 3 Mile Island, Chernobyl and Fukushima are the 3 nuclear reactors. Again, multiple systemic failures were responsible for this. Fukushima, you have large amount of data on all the three of them. Okay. Now a lot of political controversy is also going on about nuclear reactors. Please don't get into the politics of it. Confined to the design issues. Then Tacoma Narrow Bridge of Washington. I don't know, many of you might have seen the movie also. It is available in YouTube. You first Google and then see that bridge failing. Okay. The entire bridge will twist and then it will twist for a bridge twisting for, huge distances, feet together, meters together. The whole bridge will twist for minutes and then it will collapse. See that first and then probably you can discuss about why it has failed. Then the Union Carbide or Dow Chemicals, now Dow Chemicals, earlier Union Carbide, the Bhopal gas leak, why it has occurred? It has killed thousands of people. Okay, many are wounded for life. And generations are affected. Of course, the Union Carbide, now Dow Chemicals goes scot-free. Again, there are sociological, economical implications, but let us confine to, in the assignment let us confine to, of course, I will encourage you to learn many things through these exercises, but in the assignment you confine to the technical discussion. Then the deep water horizon oil spill. You might have heard about it. This is something which has happened recently, about a year back. An oil spill, okay, which caused havoc. Okay. So why a simple oil spill? Why can't we contain it? Some broken pipe. It is as simple as this. Some broken pipe cannot be fixed for days, for months. Throwing millions of barrels of oil into Virgin Sea and then spoiling the entire ecosystem. Can't we fix a broken pipe? So it is the problem is as simple. It is only a broken pipe. Unfortunately, we could not fix it. Then finally the Space Shuttle Columbia disaster led to a lot of human life losses also. Yes, I get the message, but I will not react to it. Unless I finish my agenda, I will not let you off. Okay. No, I have seen the watch. So, again, this is again a major engineering failure. So, do this assignment seriously. After you submit your assignment, I will discuss them in detail. Is it okay?